Greetings, everyone. Thank you for having me. Thank you for the introduction. And thank you, Mr. Mustard, for my copy of the Industrial Cybersecurity book, which is an ISA publication. I really encourage those that are either new or actually in the cyber realm to get yourself a copy and try to get one if you do get to see Steve get a actually signed version. So thank you for that, sir. And it's available at the ISA bookstore online and I believe at the conference as well. So the talk today is going to be talking about the 62443 standard and the contrast between some other methodologies such as the Idaho National Labs consequence-driven cyber-informed engineering. So I'm kind of going to walk through that, but I do want to kind of cover where we've been for the last 20, even 30 years, because there has been a lot of things that have changed. So one of the big changes has been connectivity, right? We're all connected. Everybody probably here has a smartphone, right? Many of you here may actually be plant operators that may even be able to see your alarms that are happening in the field in near real time data communication. Some of the things that have changed from the last 20 years. Definitely that has been one of the key things is that connectivity, high-speed data communications, all this stuff has really made some changes since the Y2K era. And the other part of that has been standardization. We're really from an automation discipline. For those here that actually came from instrumentation and automation, we put a lot of effort to be able to standardize our processes. And by doing so, we can save cost, optimization, training. We understand that as professionals. However, from a security standpoint, that has given, we'll say, cyber adversaries a horizontal attack surface. Meaning, if you can get into one, you can actually possibly get into the rest of them, maybe with the same package, the same payload, the same threat vector, and even the same threat scenario. So while connectivity has improved, standardization has given us a great benefit. That horizontal attack surface is exactly what our cyber adversaries are trying to use, not only against us, but also through cyber means and sabotage. So that connectivity has been a major change. Other things have been, well, we've really technically advanced. If you look here on the very bottom, that is a Sylvania Foxborough Fox 1 system. I actually got to see one of these in operation at Marysville Hydrocarbons in Michigan, and it was a thing of beauty. But it took 10 to 15 operators to run the plant facility. If you look on the right-hand side, that's the distributed control systems that we use today. And they're also highly integrated, right? So you may actually be monitoring process safety, having the same human-machine interface. And guess what? Two operators can possibly run 4, 6, maybe even 10 reactor units. A lot of things have changed. So again, the streamlining of processes, the technology, the advancements have given us that capability. But it's almost like a double-edged sword. So we have to be careful as professionals how we actually integrate these, how we deploy them, and the standards of how we're actually implementing these are going to be key to the process. And that's why ISA is so important in that strategy, especially from the ISA 99 standpoint, the 62443, but even the process safety side, the TR 84, the 84 working group, right, that are working on functional safety, also have a lot of skin in the game, as we say here in the States, on the aspects of the safety system, but also the cyber means. So there are some technical reports that now have got cyber as a part of that. And even the 61511 has got new 2 clauses where you have to assess your risk from a cyber standpoint. So it's really important as professionals, we use and utilize the international automation focus. So key things there, we heard about this yesterday. We talked about convergence. We talked about digitalization efforts. And so a lot of these things have given us wonderful, wonderful tools, optimization. As you can see, the process engineer can now get communications to their mobile phone, their iWatch maybe, right? It's all great. The thing is that if they're insecurely deployed, those could be threat vectors in that adversaries are lurking, not just on the public network, but possibly within your own enterprise already, if compromised, to be able to pivot, vector in, and compromise your systems. So we have to be very aware what we have. And one of the things that we've lacked over the years has been being able to monitor and detect what our networks are doing. Because many of the networks that we've worked with have went from proprietary to gateway systems, and some of them may not be able to handle high-speed data communication networks or scanning across these networks. Trust me, I've actually seen boilers, large-scale boilers within plant facilities actually go offline and trip just because someone wanted to do a ping scan. So these are the kind of things we must be aware of. So convergence is great. It's not going away. Accept it, adopt it, work with your teams. But we have to be very careful, especially if we're the ones at the conceptual design, the engineering design, the deployments. We need to start baking in cybersecurity at the very front end. And I'll get into the reasons why around that. So how do we tie that in? So I'm going to start here with a relevant timeline, and I want you to look at the first 10 years as this thing goes across and sweeps over to the right. And I want you to, on your hand, be able to count how many actual relevant cyber incidents happened before 2010. And then I want you to look at from 2010 to today. So as you can see, from 2000, 2001, there was maybe up to 2010, a little over a handful. Right? Okay. But look, from 2010 all the way where we're at today, it's more than tripled. We've had Colonial Pipeline, we've had JBS Meat, ransomware has become basically everything that's being discussed at the corporate level. These are things that have impacts either directly or indirectly to our operations, to where companies are having to make the choice of either paying a ransom, shutting down, losing, or having to operate in a degraded state. So the thing is, and I want you professionals to think about this, is that if we've known about cybersecurity for the last 20 years, and we're supposed to be getting better as a gold standard from an IT security standpoint, then why is that all the way on the right? Why does that look the way it does? It's because the adversaries themselves are also keeping track, and they're that couple steps ahead of us at all times. Not just flaws in software, coding errors, vulnerabilities that we find daily. And I always say this, right? At the plant side of it is that you might be secure today. By the time you wake up and go out to the facility tomorrow, there might already be another vulnerability or 0 day. And so we have to get on board with this. So key thing here is that it's important that we understand that it's only going to continue to be this way, especially with our digitalization efforts, right? So for those that are new to automation, I'm sure the book kind of covers that, the ISA material, is that we have a basic process control. That could be PLCs, that could be a distributed control system, it could be a process automation controller that tries to keep our operations in check. If they go outside that realm, then we have process alarms, we have operator intervention, we have the ability for the operator to react to try to get the systems back in normal operations. If that doesn't happen, we have our safety systems to protect us, right? They're designed to protect us. They have safety layers of function to be able to protect us. And if they don't, then we have a bad day, right? We're looking at rupture valves, relief valves, rupture discs, containment dikes. It's a bad day. What you're seeing over on the right-hand side is what has changed over the last 20 years is that we're now fully integrated. So now your SIS, your safety instrumented system, and your basic process control, which used to be completely islands from each other, have now been intertwined or have some network connectivity or capability. And so that's exactly the kind of things that adversaries or engineers with nefarious possible intent would want to be able to get to. Another thing that's happened is COVID happened, right? How many operators that are out there actually went through emergency management and change to allow their engineers to be able to get to the basic process control, to be able to do monitoring, to be able to do health statuses, Even open up asset management portal to even maintenance technicians to look at the health of their transmitters. So a lot of that has changed in the fact that something like a pandemic has now allowed us to open up these communication links to get closer to the actual process under control. And that can be good, but it can also be very dangerous, especially if you're coming from a home network could already be compromised. Think about that. So those are the key things. And you talk to folks that say, well, we have a firewall, our enterprise IT, monitors that's deployed. The thing is, there are some myths around it. I want to cover some of the things that we constantly find in the field. My team goes out and does risk assessments, and a lot of it comes into play with the DMZ misconception that we have a firewall. And a lot of times it's the unauthorized connections that will get you. And what I mean by unauthorized connections could be communication links that are to an adjacent OEM system that might have communication to it, that could be coming from the internet, bypassing all the things that you've done in your enterprise, in your levels and your zones and conduits that 62443 defines, that could be actually went around, right? Misconfigured firewalls. You wouldn't believe how many firewall configurations we look at today that still have any rules within them. In other words, they're really not having any filtering whatsoever. We recently did a risk assessment on one that actually had no filter rules. It was just acting as just a appliance. So they checked the box on compliance, but there were no rules in it. So we have to get better at that. Other pieces to this, obviously, are going to be, we still see modems that are out there, cellular. So they got rid of the plain old telephone line and put in the cellular links. Those are found out there. And yes, the unverified trust is a serious piece, is that we trust our vendors. We trust our OEM support, but we don't know who the other person on the other side of that keyboard is. We've actually seen where OEMs have used corporate networks to actually be their digital playground, right? And try to do communication hunts, try to actually use tools such as Jack the Ripper to try to actually crack passwords. So we have to be very, very, very cognizant of that. And then, yes, these adjacent PLC networks where you might have two pipelines that are selling off to each other. Some of these communication links may not even have any type of barrier between them or any type of security appliance between them, and they could be exposing their network up to your network. And that could be a serious concern because you cannot control what their cyber maturity is and their roles, responsibilities, and how they operate, but you can control yours. So we have to identify those. And a lot of times going out into the field, you'll find that what you have on your drawings may not be what you have in the field. Boots on the ground is paramount in your assessments. So where am I going with this is the fact that we have a lot of pieces to it. We've got infected laptops that can happen, downloading a driver, trying to do your job in the middle of the night, can't communicate with a certain PLC, going to the internet, pulling in some malware, accidental, and now infecting it into your system. So we have to be very aware of that. So the traditional ways. Other parts to this is that we have been accepting technology into our field for the sake of cyber, right? And you got to connect it to protect it is IT's form of strategy from their professional side, which makes sense for them. However, that these can also be active on your network and can also be a vector into what you're trying to protect. So we have to be careful in the deployment of those. And then, yes, your actual field instrumentation, your valves, your HART communicators, your asset management systems, these are all playing a part into this whole digital strategy that we call IACS, or Industrial Automation Control Systems. And that is the difference between ICS and IACS based off the standards is ICS is software and hardware. IACS is the people, the process, the technology, and the safety aspects of it. So it's important that piece is known because the blade does cut deep. So what we see today is that we have geopolitical tensions, right? We have war that's happening where there's countries that are involved in this. So we have huge targets on it. Not to mention hacktivism. That's also increasing. We've got folks that are targeting pipeline, folks that are targeting maritime, for example, because of emissions. And so those are big pieces, is that we have nation states that are out there that have capability. The other piece to this also is that it's not any one vendor. The fact of the matter is that the ICS cert, you'll find that it's just a bowl of soup of the different vendors, because these code-driven devices can have flaws. And like I said, what's secure today may not be secure tomorrow. And the thing is that threat actors are taking these devices, they're able to get their hands on them and actually reverse engineer them. And that's scary. We weren't dealing with that 30 years ago. We were just really worried about bugs in software, a not block, not nodding in our control strategy is an issue, right? But having something now changed in that block, not aware to you, the engineer, are the things that we're having to be concerned about. So that is the blade that cuts deep, is that we have to get very serious with what we're doing on, especially from a security standpoint. So what are people ask me, Marco, what are the things that you're seeing around in the area? And a lot of it comes down to ransomware. People are concerned about ransomware. The part that's really intriguing is the fact that it may not hit your control system side. We have seen instances here where it has in MTSA facilities, where actually you go to the HMI and there's an actual ransomware screen showing, but there's been non-direct impacts. And what I mean by that is that if it hits the enterprise, can you shut your enterprise off, or do you even know the demarcation to be able to pull the plug? I challenge you, go back and talk to your folks and say, where's our line in the sand to where if we had a ransomware outbreak, we could disconnect and operate? And especially for those that are in the audience that have enterprise SCADA, that might be a challenge for you, because there's so many interdependencies. There's not only the enterprise, the ERP side of it, the management execution system of it, the billing, the tolling, all these things are intricate pieces of it. And that's where we've gotten to it as an industry. So we need to be able to find where that is. And the processes around the standards-based approach from 62443 and the CCE, the consequence-driven cyber-informed engineering, can provide two different paths or a hybrid path to be able to not only assess it, identify it, but also protect it as engineers and specialized technicians that you are. So other pieces here, I think we talked about that poor segmentation, unauthorized connections, see that a lot, unauthorized remote access applications. The team viewers, the real VNCs, the ultra VNCs, the RAdmin, there's so many actual remote access tools. It's dumbfounding. And we see that a lot as beacons, even offshore and even in the onshore circuit. And then third-party OEMs with no former cybersecurity training on the actual systems that they're working on. So it's a culture. It comes to awareness. It comes to training. But ultimately, you've got to help drive that culture. All of us here have a very strong safety culture. At their work environment, at home, safety is paramount. Safety is number one. Cyber, with the systems that we have today, we need to make that also a priority. So risk-based performance standards is one aspect. Behavioral-based safety, we need to think about behavioral-based cyber and how we can tie that in to actually an assessment strategy, a life cycle. Why is this important? And this is actually from 2021, is that people do silly things. Here's an example of Sabotage that went to the actual federal court system for an indictment, which is a felony, where they rendered the safety systems inaccurate on an offshore platform. You can look this up. This isn't TLP green or amber, but just to let you know, we're still dealing with folks that have the capability, the intent to tamper with systems. So it's not just cyber, but now we've also given a means in some instances where we leave our engineering workstations open, right? So people are bypassing things, they're forcing values. And that is absolutely something that we don't want to happen. So we're dealing with all aspects: geopolitical, hacktivism, cyber espionage, the human factor. And that's why it's important to find an assessment strategy that you could use in your environment, because only you know your environment best, how you operate. Because traditional risk and the strategies around that what we always try to do is we try to find out likelihood or probability, right? And so the thing is that in safety, we have a lot of information. We know how transmitters fail. We know the mean time to fail, but how do we do that with cyber? How do we quantify that? How do we understand what that is? We know how risk matrices work. It's not anything new to us. The thing is that how do you estimate likelihood or probability of a malicious actor that you have no idea what their intent is, right? And so some of the parallels between 62443's risk assessment do capture that, but they try to help you quantify the likelihood or identify that. And CCE gives you a different starting point. And I think it's important that we utilize a starting point such as CCE. So some of the key things for those that raise your hand if you're following 62443 in your plant environment. Excellent. Very, very good set of standards. We teach the standards. ISA's got 4 cyber classes, the IC 32, 33, 34, and 37. This is actually pulled from the risk assessments training from IC 33, which covers the piece that you're going to perform a high-level risk assessment. Is this going to impact you? Is cyber really an issue? Are you mixing water paints that are biodegradable at atmospheric pressure? Probably not, right? Y'all have complex processes, dangerous chemicals, high pressures, high temperatures, all these things that matter. And so the key piece here is that you're going to end up performing a detailed risk assessment. And the 62443 actually provides you a template, a roadmap to be able to get into your risk assessment strategy. Many companies are following this. And by doing so, it helps you identify your vulnerabilities. Obviously, if you're running XP, you probably know you have vulnerabilities, but other vulnerabilities, such as if the firewall has, allow any-anys, if a device has a modem or has some type of outbound reach to the internet. Identifying your vulnerabilities, identifying your threats, determining what your actual impacts could be, and then also the likelihood. And a lot of companies, this is where it gets a little bit strange. I think it gets a little bit subjective when it comes down to likelihood, because you may have somebody in a workshop that says that'll never happen in 100 years, or it's never happened to our plant in 30 years. Well, you're not using those pneumatic relay panels anymore. They're all code-driven devices with network communication and links. So a lot has changed. So coming up to a kumbaya moment with your team, going through these is very important. And so a lot of the things here that tie into CCE are still there and need to happen. And a lot of this can come from PHAs, HAZOPs, LOPAs, previous vulnerability assessments. And so this isn't a deep dive in the standard, but I do encourage you to take the 33 training. And so other pieces to this is determining your unmitigated likelihood, determining your unmitigated cybersecurity risk. What is risk to you? What is your appetite for risk? How do you treat, tolerate, terminate, or transfer that risk? If you can, you may not be able to. And so those are key elements to that. And then determining a security level target. Everybody should know that there's 5 levels, 0 through 4, 4 being the highest level, geared towards nation state, cyber criminal, people with high resources, high impact capabilities. And then coming through the rest of the actual assessment is, if there's tolerable risk, can you actually find a way to remediate that? What are some of the recommendations around what you can do to actually lower the impact? And you go through this cycle, right? It's just like a HAZOP, right, or PHA. What if we add another barrier? What if we add another, double block and bleed, right? Same idea here. Maybe we should add some more firewall rules. Maybe we should put a data diode in. All these things come into a risk assessment strategy. But again, subjectivity around not the consequence, but the likelihood and the probabilities. Because a lot of folks try to tie that into your risk matrix, which is fine, but just know there's some subjectivity around that. So key piece here is that if you're a fan of Feynman, you can go through a lot of complex math, right? And cyber defenders spend a lot of time and money on technology, on monitoring, and doing all these things just to try to calculate likelihood. And the fact of the matter is that here's the probability and truth, is that Critical infrastructure will be targeted. We know that, we've seen that. And that when targeted, it will be compromised. So for those that are trying to understand what are the likelihoods, probability, we're a small chemical plant out in the middle of rural, Midwest. Why would we be a target? If you have communication links, you're still part of the supply chain. These are things that PHAs, HAZOPs, and locals never even look at or take it for example. And so this is INL's probability here is the fact that we have to take likelihood as a Boolean. It's not if, it's when. So we have to go into the process as though it's going to happen. So what do we do now? As engineers, as designers, as architects, we got to build around that. So CCE, the consequence-driven cyber-informed engineering, goes through that piece of it. And basically, it unravels, same as the 62443, but it quantifies the likelihood as 1, right? So you get past that through your discussions. And then the key piece here is that there's 4 phases as opposed to the structure of a 62443 3-2. And I am a firm believer that you could accommodate for both. A 3-2 standards-based approach with a CCE mentality going in with your likelihoods. So here's the thing. As we go through this process, we've identified high consequence events. We talked about it in 62443 3-2. We've documented that. But what we may not have actually looked at is where are we at in the supply chain? Can we be down for 7 days? What if a cyber actor actually wants to kill our company? Not explode the plant, not have a release, not have a loss of containment, but they just want to shut our systems down or kill our actual logistics chain. That's what CCE does. It goes a little bit further up and looks at it and then dives down into the actual systems. And that's the piece of the system of systems. Talking about IACS, the people, the process, the technology, that's the idea of CCE, is diving into that and determining where those threat vectors are, the who, the what, the how often do you communicate with that system? How is it designed? And really understanding where that's at and where could there be a threat insert? And then it gets down to targeting and understand that this is the piece where you really need to work at saying, well, if our plant, for example, was hit in the middle of winter, how would we be able to operate? Stop using sunny day scenarios in your risk scenarios. You need to start thinking like an adversary. Think like an engineer, think like an adversary. If you're going to do it, what would you do to protect yourself, from your own engineering side? And then kill chain mitigations. We put a lot of adoption and a lot of faith, maybe a lot of blind faith in technology and digital communications. I think it's great that we have it, but I think we need to go back to our engineering roots and actually put maybe some of the technology that we had back in. For example, when you go to hit an emergency shutdown button, those now go into SISs now as inputs. Back in the day, those actually go and kill DC bus or AC bus to all the solenoid valves. Some of that just to be able to protect ourselves if our systems, when compromised and unavailable to a non-operational state, we've got to be able to have an ability to shut down and isolate. And so the conclusion is there is 62443 3-2, along with the CCE strategy, is the best approach that I've seen to date. Many people will probably say they have their own methodology, which is fine, but this